This is an example of the visualization function, which visualizes historical bus operation data. By selecting the date and the route of the buses, you will be able to see the details of the specific operation data. One way to forecast the future is to learn from similar situations in the past. Hence, you will choose the data of Route 44 on October 12, 2019, which is the bus route to the stadium on the day of a college football game. Now, let's take a deep dive into the comprehensive analysis of the bus operation based on KPIs. This is the screen of the KPI analysis. The graph on the left shows the total number of passengers at each stop on Route 44 per each hour. You can see that the number of passengers between 9 and 10 o'clock is the highest. The graph on the right represents the load factor of the busiest section of each bus. You can see that the buses running between 9 and 10 o'clock are operating beyond their full capacity. Now, let's check the details of this specific bus operation on the map. This is the visualized historical operation data of the crowded bus specified by the KPI analysis. The circle represents the bus, and the color indicates the level of crowd inside the bus, where red means the bus has gone over its full capacity. Between 9 and 10 o'clock, the bus is most crowded at the station closest to the stadium, and it could be assumed that these passengers are heading to the stadium. Next, let's do a simulation and see whether we can reduce the crowd in this bus. This is the menu screen of the simulation. MaaS orchestration is planned to have 4 simulation elements, which are A. Add transportation modes. B. Increase or reduce service frequency. C. Create or abolish routes. D. Inform or incentivize passengers. These functions will leverage historical data and machine learning to simulate how the number of passengers change when such elements are altered. We will select D to see whether we can reduce the crowd inside the Route 44 bus by passenger incentives. This is the screen of passenger incentives simulation. First, we will enter the conditions for the simulation. Select a date when a college football game was held in the past, and enter other conditions for the simulation. Click Actuals Forecast button, and you will see a ranking chart showing high passenger load buses on that date. You can see that the buses that ran on Route 44 between 9 and 10 o'clock were operating 20% beyond their full passenger capacity. Now, we would like to balance the passenger load during this time period. This time, let's try distributing coupons to potential passengers and see how it influences the passenger load. Fill in the items under Select an Incentive, types of coupon, location, and valid time period. Then press Actuals Forecast button. You can see how this passenger incentives influenced the ranking chart below. The passenger load of the targeted buses has now gone down below 100%. Apparently, some passengers chose to arrive at the stadium earlier to use the coupon. Consequently, the number of passengers on the buses between 8 and 9 o'clock has increased. Next, let's take a closer look at the result of the simulation using the visualization function. Select the After button on the upper right to check the simulation results. The blue bars represent the actual number of passengers on October 12, 2019, and the red bars reflect the result of the simulation. The graph on the left shows that a certain number of passengers who were on the buses between 9 and 10 o'clock has now shifted to buses running between 8 and 9 o'clock, evening out the load. The graph on the right shows that the buses running between 9 and 10 o'clock are now running within their passenger capacity, while there is some increase in the number of passengers on the buses running between 8 and 9 o'clock. From this, you can see the effectiveness of passenger incentives when balancing the passenger loads. Next, let's see the output of this simulation more visually on a map. No bus seems to be exceeding its full passenger capacity. The result of this simulation is showing the effectiveness of passenger incentives when balancing the passenger loads.